Good morning, all viewers. In the last class, I told you about index numbers. What is an index number, and what are the various classifications of index numbers? That is, we'll come across price index number, quantitative index number, value index numbers, and special purpose index numbers. And after that, what are the problems that are involved in these index numbers? Now, today I'm going to take into account the methods of construction of index numbers. Now, when you go for methods of construction of index numbers, we'll have two methods: unweighted indices and weighted indices. Unweighted indices and weighted indices. Unweighted indices are nothing but where the weights are not assigned to the data, and weighted indices are there where we'll assign the weights to the given data. And unweighted indices, they are again of two types: simple average, simple average index numbers, and simple average of price relatives index numbers. So what is simple average? Simple aggregate methods. This is the simplest method of constructing index number. Under this method, the price index is calculated. The total of current year prices for various commodities is divided by the total of base year prices, and the quotient is multiplied by 100. Okay, this is the method that we will come across in simple aggregate method. That is, we have to total the current year prices. We are talking about price index first of all, so we have to take into account the current year price in the prices total, as well as base year prices total, and converting, I mean, dividing this current year index numbers total with base year index numbers total, will get one value, and that value, if you multiply with 100, automatically you'll come across this index number symbolically. Okay, p01 stands for index number. P, price. O, that is base year, and 1, it represents current year. So p01 is equal to sigma p1 by sigma p0 into 100, where sigma p1 is total of summation of current year price index prices of various commodities, and p0 is nothing but the total of base year current base year prices, the total of base year prices. Okay, steps: first, add the current year prices for various commodities, that is sigma p1, and second, add the base year prices for various commodities, that is sigma P0. Divide sigma P1 by sigma P0 multiplied by 100, you will come across the index number. So when you go for index number, when you go for the result, it means that comparative to base year, what is the increase in the prices, what is the percentage of increase in prices, similarly what is the percentage of decrease in prices. These are the various this is the method that will come across. And simple average of price relatives, when this method is used to construct a price index, first of all price relatives are obtained for various commodities, and then average of these relatives is obtained by using any one of the method, that is arithmetic mean or geometric mean. Okay, to take average of price relatives. And what are the steps for this? Sig p01 is equal to sigma p by n, where p is equal to p1 by p0 into 100. Here p stands for price relatives. Okay, so sigma p by n is equal to arithmetic mean. That is, using arithmetic mean we will come across. So when geometric mean is used, log p01 is equal to sigma log p by n, where p is equal to p1 by p0 into 100. That is, we have to take into account the percentages, and then we have to do that. p01 is equal to antilog of sigma log p by n, that is by using this geometric mean. So this is the second method in unweighted indices. Now coming to weighted indices. Weighted indices are those indices where weights are assigned to the given data. The unweighted index numbers are not the unweighted index numbers are not suitable in the true sense, that is, they won't give correctly. They assign equal importance to all the items included in the index, and weighted weighted indices, they'll take into account the implicit rather than explicit of the construction of useful index numbers. Okay, now to assign each commodity a weight in accordance with its importance in the total phenomena. So, weighted index numbers are also of two types: weighted aggregate indices and weighted average of price relatives. These are the two things that we will come across in weighted indexes. Okay, now weighted aggregate index numbers. These indices are of the simple aggregate type with the fundamental difference that weights are assigned to the various items included in the index. There are various methods of assigning weights, and a large number of formulae for construction index numbers have been devised. Some of the important ones are: first, there are 6 methods in this weighted aggregate where we will assign weights. So first one is Laspeyres method. It is represented by capital letter L, Laspeyres method. Second one is Passish method. It is represented by P. And third one is Darvish-Bowley method. Darvish-Bowley method. And next one is Fisher's ideal index number. And fifth one is Marshall-Edgeworth method. And the sixth one is Kelly's method. These are the 6 methods that are there in weighted aggregate index numbers. Now, one by one, we are going to study Laspeyres. In Laspeyres index number, we are going to give we are going to take into account the quantities. Here, quantities are nothing but the weights assigned to the prices. So, the weighted aggregate price index will get as P01 is equal to sigma P1Q0 by sigma P0Q0 into 100, where P1 is equal to current year price, Q0 is equal to base year quantity. That is, we have to take the product of current year price and base year quantity. Similarly, base year price and base year quantity. So P01 is equal to sigma P1Q0, sigma P0, sorry, P01 is equal to sigma P1Q0 by sigma P0Q0 into 100. This is the methods. What are the steps? Multiply the current year prices of various commodities with base year weights and obtain sigma P1Q0. Multiply the base year prices of various commodities with base year weights and obtain sigma P0Q0. Divide sigma P1Q0 by sigma P0Q0 and multiply the quotient by 100. So the primary disadvantage of this method is that it does not take into consideration the consumption pattern. Okay, that is the main disadvantage that we come across. Now coming to second method, that is Passish method. So in this, there is a weighted aggregate price index in which the weights are determined by quantities in the given year. The formula for construction of the index number is P01 is equal to sigma P1Q1 by sigma P0Q sigma P0Q1 into 100. Once again, I am repeating. P01 is equal to sigma P1Q1 by sigma P0Q1 into 100. So, this is the method to construct the price index numbers as per Passish. What are the steps? Multiply the current year prices of various commodities with current year weights and obtain the total sigma P1Q1. Then, second one is multiply base year prices of various commodities with current year weights and obtain sigma P0Q1. divide sigma P1 Q1 by sigma P0 Q1 and multiply the quotient by 100. The difficulty in computing is that revised weights or quantities must be computed each year and each period, adding to the data collection expenses in the preparation of the index. So you will come across an expensive aspect in this passage method. That is the difficulty that you will come across. Now coming to Darvish and Boole method. So according to this, P01 is equal to L plus P by 2. That is, we have to take the average of the previous two methods, that is Las-Paris and Passy. P01 is equal to L plus P by 2. That is the method. And the full form of the formula is P01 is equal to sigma P1 Q0 by sigma P0 Q0 plus sigma P1 Q1 by sigma P0 Q1 whole by 2 into 100. That is according to Darvish and Boole method. That is, we have to take the average of the Las-Paris as well as Passy. Now after that, Irving Fisher he had given an ideal index number, and most of the people they will concentrate on Irving Fisher's index numbers only. So in Darvish and Boole we have taken the average. Now in this Irving Fisher we have to take into account the square root of product of previous Las-Paris and Passy. So Professor Irving Fisher has given a number of formulae for construction of index numbers, and these he calls one as the ideal index. Fisher's ideal index, okay, is geometric mean of the Las-Paris and Passy indices. So P01 is equal to square root of L into P, geometric mean of Las-Paris and Passy. So the full formula is P01 is equal to square root sigma P1 Q0 by sigma P0 Q0 into sigma P1 Q1 by sigma P0 Q1 into 100. So this is the ideal index number given by Irving Fisher. Now Marshall-Edgeworth method. Marshall-Edgeworth method. He had taken quantities of base year as well as current year multiplied by current year price. Similarly, base year and current year quantities multiplied by base year price. The formula is P01 is equal to sigma P1 Q0 plus sigma P1 Q1 by sigma P0 Q0 plus sigma P0 Q1 into 100. That is, he had taken the quantities, he had given much importance for the quantities, and that quantities he had added and multiplied by the current year price. Similarly, the base year quantity and the current year quantity he added and he had multiplied that with base year price. So this is the formula given by Marshall-Edgeworth. Now Kelly's method. This is the sixth method that we come across. The following formula for construction of index number is sigma P min P0 Q0 P01 is equal to sigma P1 Q by sigma P0 Q into 100. Here weights are quantities which refer to some period. Thus, the average weight quantity of the two or more years may be used as weights. So, sigma P1, sigma P0 Q, P01 is equal to sigma P1Q by sigma P0Q into 100, where Q is equal to Q0 plus Q1 by 2. That is average. You had taken the average quantity and you had done that thing. So this is how we'll come across regarding the Kelly's method. Now, after that, whatever it may be, the index numbers that we are computing, okay, some tests are to be conducted. Okay, some tests are to be conducted, and when we are going for the test, automatically whether that index number is correct or wrong, we can able to understand that. So after taking into account the tests, okay, after taking into construction, after taking into the construction of index numbers, we have to test Okay, so what are the tests that we will come across? Unit test, time reversal test, factor reversal test, and circular test. These are the four tests that we'll come across to find whether the given index number or whether the constructed index number is reliable or not, is good or not. We have to take into account that thing. So unit test. So the unit test requires that the formula for constructing an index should be independent of the units in which prices and quantities are quoted. This is about the unit test. Now time reversal test. Professor Irving Fisher had made a careful study of the various proposals and has suggested various tests to be applied to any formula to indicate whether or not it is satisfactory. The most important of these he calls the time reversal test and the factor reversal test. Time reversal test is a test to determine whether a given method will work both ways in time, forward or backward. So the test is that formula for calculating the index number should be such that it will give the same ratio between one point of comparison and the other, no matter which of the two is taken as base. Symbolically, the following relationship should be satisfied. That is, P01 is equal to P01 into P10 is equal to 1. That is the final test that he had given according to time reversal test. P01 into P10 is equal to 1. The answer must be 1. Then only we can say the index number satisfies or it is prominent and it is reliable. Okay, where P01 is the index for time 1 on time 0 and base, and P10 is the index for time 0 on time 1 as base. So the formula is, okay, when Laspeyres method is used, we are using this P01 is equal to sigma P1 Q0 by sigma P0 Q0, and we are just reversing, that is P10 sigma P0 Q1 by sigma P1 Q1. So when you multiply sigma P01 P01 into P10 is equal to sigma P1 Q0 by sigma P0 Q0 into sigma P0 Q1 by sigma P1 Q1. It does not satisfy. So similarly, last pair is also, it won't satisfy this when Fisher's ideal index is used. When Irving Fisher's ideal index is used, we have to see whether the test satisfies or not. P01 is equal to square root P1 Q0 by P0 Q0 into sigma P1 Q1 by sigma P0 Q1. Now we are going for reversal of the time, that is base year to current year to base year. P10 is equal to square root sigma P0 Q1 by sigma P1 Q1 into sigma P0 Q0 by sigma P1 Q0. So when you multiply both these things, okay, all the values they will be cancelled and you will get square root 1. Square root 1 is equal to 1. The other methods which satisfy the test are simple geometric mean of price relatives, aggregates with fixed weights, weighted geometric mean of price relatives when fixed weights are used, and Marshall-Edgeworth method. These are the other methods which satisfy the time reversal test. Now coming to factor reversal test. Another test suggested by Irving Fisher is known as factor reversal test. In this, the product of price index and the quantity index should be equal to the corresponding value index, just as each formula should permit the interchange of the two times without giving inconsistent results. So it ought to permit interchanging the prices and quantities without giving inconsistent result. That is, the two results multiplied together should give the true value ratio. If P01 represents the change in price and current year and Q01 the change in quantity in the current year. Then P01 into Q01 is equal to sigma P1 Q1 by sigma P0 Q0, which is nothing but the value index number. Okay. And only Irving Fisher's, okay, added index numbers, only it will satisfy. P01 is equal to square root sigma P1 Q0 by sigma P0 Q0 into sigma P1 Q1 by sigma P0 Q1. And coming to Q01, Q01 is equal to square root. Here we are keeping quantities fixed. The prices they may change, but quantities they will be same. So what is this Q01? Square root sigma Q1 P0 by sigma Q0 P0 into sigma Q1 P1 by sigma Q0 P0. So this is the formula. And when you use this, when you multiply P01 into Q0, P01 into Q01, the resultant will must be sigma P1 Q1 by sigma P0 Q0. This is about the Irving Fisher's factor reversal test, and we will continue this in the next class. Okay, and those people who require any commerce and account subjects, you online tuition, you please call me to this number 9849238902. So please avail this. Okay, and when you require the online tuitions, you please contact this number and get your services. And if my this thing is good, okay, please subscribe to my channel. Don't forget, please subscribe to my channel. Thereby I'll get some inspiration to continue these classes. Thank you very much.